Okay, what's up, team? It's your boy, the Canologist. I'm going to be doing another Leetcode problem today. So let's close that. Let's figure out what I want to solve right now. Intersection of two linked lists. Okay. Given the heads of two singly linked lists, head A and B, return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. Begin to intersect at node C1. Okay, cool. So this is the example. Okay. I might need the whiteboard too for this. So let me pull up my whiteboard app. Oh no, I have it right here. The thing I don't like about this whiteboard is you have to keep resetting the settings on here. So now I have this. Get my eraser. Get this. So that's the kind of size I want for these. If I want to draw things. Okay. So test cases are generated such that there are no cycles anywhere in the entire linked list structure or linked structure. Okay. Test generates no cycles. Okay. Cool. So if there's no cycles, we can't use the tortoise and hare pointer method, where you get one that's moving a certain speed and one that's moving double the speed, so they intersect. Note that the linked list must retain their original structure after the function returns. So we need to create some sort of pointer base. This is telling you need to return some sort of pointer based solution, because you can't modify the linked list. It has to be exactly the way it was. Custom judge. Okay, so judge given the inputs. Value the node where the intersection occurs. This is 0 if no intersected. Okay, cool. A, B. Okay, so that gives us head A, B. Skip A. Number of nodes to skip ahead in list A to get to the intersected node B. If you correctly return the intersected node, your solution will be accepted. Okay, cool. Protein and water. What does that taste like? You know those communion candies, those fucking little white balls of candy with the almond like center? If you drink this protein milk and then you drink water directly after it, you mimic the taste of that candy. It's been a while since I had that. Anyways, so input. Output intersected at 8. Okay. This is so complicated with the way they're making it out to be. Because look, they give you the head node A and head node B. They can't actually give you the entire list. They can, because it's a linked list. So the way a linked list works is you have the address of one node, and that node has a direction that it can follow. If it's a singly linked list, it only goes to the end until it reaches null. If it's a doubly linked list, you can move forwards and backwards between nodes. Alright, so I have a singly linked list here, and I have two of them, and they might intersect. So they give us head A. They give us the head node because this is the only node that you have the address for. You don't have access to the rest of them. So the only way to look at the rest of the nodes is to go from the head node and then traverse it all the way till the end, right? And you have to do that for A and B. So if you do that for A and B, so this is how you do a linked list. Use a linked list. Node, 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 node. You're only given this. These are how they're connected. So you're given a node, let's call it N, and you're given a pointer, let's call it P. And every node, let me change the color here. So this is what a linked list is. This is what a node consists of. A node and a pointer. So this is the complete node object. It's a node and a pointer to the next node. And then the next object is another node and a pointer to the next node. Another node, a pointer, until you finally reach the final one that goes to null, which means you're at the tail node. This is called the head node. Let's call it H, or let's call it head. Forgive my writing. I know there's always going to be one fucking person in the chat saying, yo, the writing's so messy, I can't tell what it is. Okay, fine. For you, I will do this. So that's the head node. This is the first one that you get the address. So if you have this, you can traverse. You have to traverse to the next node and the next node using these pointers. So the pointer is called .next. So if you go this node .next, you're basically looking at the next node. And then this node .next, you're looking at the next node. So if you go this node .next, you're looking at this node. So you can skip directly to the second node here. This is the tail node. The tail node is the one where you know for sure the linked list ends because it points to nothing, null, or none, right? So if you understand this concept, if we go back to the problem, let's take this lasso first, and let me just clear out everything on the page. Delete. So if we go back to the problem, you get two linked lists, right? So you start with the head node, boom, 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 traverse. Okay, we want to find the points where if we traverse both lists, where they intersect, right? So now there's some other bullshit called a judge. So this is what they're using to test your input, your solution. So inputs are given to the judge as follows. Your program is not given these inputs, right? So your program, so this is our program. You just get A and B as the address, right? But the judge, when it looks at your solution, it's given a bunch of the correct answers on the back end side. And based on these criteria, it determines whether your solution is correct. Because it's going to find the head node. Not the head node, it's going to find the intersected node. Right? So with ours, we're just going to look at the example 1. Intersect value 8. So if I'm looking at this intuitively, 8 is the value. Okay, list A, 4 and A, 5B. Okay, so 4, 1, 8, 4, 5, 5, 6, 1, 8, 4, 5. Okay, so that's B. List A, list B. A skip 2. Okay. B skip 3 to get to the intersected node. Okay, let's look at the explanation. The intersected node's value is 8. Note that this must not be 0 if the two lists intersect. Okay. Start from the head node of A, it reads 4 and 8, 4, 5. Head node of B, it reads 5, 6, 1, 8, 4, 5. Okay, so that's fair. There are two nodes before the intersected node in A. Okay. There's 3 nodes before the intersected node in B. Note that the intersected node's value is not 1 because the node's value with 1 in A and B, second node in A and third node in B are different node references. In other words, they point to 2 different locations in memory. Ooh. Okay. While they point to 2 different locations in memory, while the nodes A8 and A and point to the same location in memory. So this is where the clue is. How do we figure out if we're looking at the same node, if it has the same value, right? So for example, A has 4, 1, 8 till it hits 8, right? and B has 5, 6, 1, 8, right? But both nodes before that node 8 are 1. So if you were to compare lists, people would be like, all right, wait, why can't 1 be the answer, right? And 1 cannot be the answer because it doesn't share the same slot in memory. So my first thing that I'm trying to think of is okay, fine. How do I figure out whether the pointer to the next node is sharing a slot in memory? So that's what I want to look at. So let's just look at B. 1912. So in this case, there's no matching number. So we have to figure out a way to figure out if 2 is sharing a slot in memory between these two lists. So intersection A, 2. List A, 19124. List B, 324. Skip 1, skip 2, whatever. Intersect the values 2. And B, intersect the value is 0 because it's not, there's no connection, there's no shared slot in memory between the two lists. So the lists do not intersect. So let's look at the constraints first. Number of nodes of list A is in the M. Okay. Number of nodes of list B is in the N. 1M. As is 3 to 4. Node value. Skip A, skip B. Intersection value. Could you write a solution runs O and N plus N and time use only one memory? So if you're using only one memory, that tells you right away it's a pointer, because you're not, no matter what you do, it's always going to have a constant value. It's not going to scale with the number of inputs. So that tells you that's O of 1. O of N plus N means you have two lists. You're going to traverse using O of N time on two different lists. So if you have two different lists, you have two different lengths. So you can't go O of N squared, so they just call it O of M plus N, right? If you had two lists that are the same size, it would be O of N squared, because it'd be O of 2N. Actually, no, it would be just O of N plus N. Fuck it. Ignore that. Okay, so we did all this. How much time do we have? So we spent 12 minutes analyzing the question. What do I want to do now? So the first thing I want to figure out is, how can I check if a pointer shares the same memory space? So Python check if a pointer shares the same memory slot as another pointer. How do you check if two pointers point to the same object? Equality operator. A bit of facts here is the relevant. So pointers point to objects of the same type. But is this for Python? No, it's not. So I gotta do this in Python. C++, you could do a strict equals, I think. Python. When do two variables point at the same object in memory? Okay, cool. It's quite a simple run to check this test. Okay, so O of n plus m. This is what gets me curious. I need to answer that question in order to solve this problem. Check if two Python addresses have the same memory address. Duplicate. Okay. Which have the whole identical data. That's what is for. For strings and numbers, you can't rely on ID. So I'm going to say I'm kind of lost a little bit because it's not clear as to how I can check if the same slot of memory. I'm going to use is. I could store all these values in all the nodes, and that's what I think I want to do. So what I'm going to do is O of n plus m. Right, that means traversing two lists. So instead of going O of 2n, it would be O of n plus n. So that tells me right there I can create two lists of the nodes of arrays stored. So what I'm going to do is create stores A, empty list, stores B, empty list. Okay, so I have two lists. Then the next thing I want to do is I want to traverse the entire string. So I'm going to create a helper function using recursion. Oh no, but I have to use O of 1 memory, so I can't use recursion. So what I'm going to do is I'm just going to use a while loop. While head A is not equal to null, while head A is not equal to null, so head I'm gonna go stores A dot append head a dot value, head a dot value, and we go a equals head a dot next. So it's going to keep traversing until it hits null. Then I'm going to do the exact same thing with head b and stores b. So it takes all the values and it puts it in there. Oh, but I don't want the value. That's a good point. That's a good point. I don't want the value. I want the entire node. I want the entire node. So I'm going to put the entire node in the list. It's going to be a list of objects. Then I can compare the objects to see if this is this, right? So let's just copy this first. So right now I'm hitting O of n plus m time because I'm going O of n and then O of m. So you have to add them. When you have while loops, when you have two separate loops, you have to add the O of n time. So Control V. Oh, what the fuck is going on here? Control C. Let's go Control V. Control. Ah, shit! I have to do it on my fucking Mac. Okay, so we got Control C. Control V. Okay. Head B. Stores B. Head B. Head B. Head B. Okay, so this allows me to get all the nodes of both lists. So let's say we go A1, A2, C1, C2, C3, that goes to stores A. Then I go B1, B2, B3, C1, C2, C3, that goes into B. Now I want to check the now I want to check the values of the nodes. If I can go, no, but it's a list. So the other thing is now I need to check if a value is the same object as the value in this list. So now I gotta find the converging value. So I know how to do it with a brute force method. I'm trying to figure out how I can do this with a I could do the tortoise and hare method as well to find the intersecting value. So I'm just thinking. How much time do I have? So I'm at 24 minutes, almost at half an hour. Let's just try and brute force it. Let's go 4 items in A. Let's call this val A. 4 Given the heads of the two, return the node at which the two lists intersect. So we're not returning the value, we're returning the node. So otherwise we can just return none. That's the base case, return none if it doesn't exist. It does exist. So for val b, in stores b, if val a is val b, so if this node is this node, right, they're equivalent, return val a. So that returns the node. So basically, this is my solution. It's going to run within the other one. Let's see if this works. Null is not defined. Oh, I put null here. This doesn't exist in Python. It's called none. Okay, that's fine. Syntactical sugar, whatever the fuck it's called. Solve that. Time limit exceeded. Okay. Time limit exceeded. So what if I do this? Python check. Let's see if a check common elements. Using the intersection function. Okay, cool, awesome. So we have this. Common elements comparison between two lists. Okay, list 1, list 2, list set. Intersection, list 2. Oh, this is perfect. This kind of returns the answer. Because if I'm doing it by node, it's not the value, it's the actual object. So these objects intersect. So you'd only get one answer. So if I go list, so I create two lists of objects and then I just get the intersecting list. So that's actually as good as it fucking gets. But I gotta return the actual node. So I gotta return the list. Could I just do it like that? Okay, let's try it first. Let's try out my theory. And then let's see if it actually works in practice. Okay, so I already have let me delete this for loop because it takes too long. Right? So what I'm gonna do is list. I don't know what to put as the if statement though. Oh, okay, let's try this. So list let's call this inter equals this. Inter equals list set set list 1 intersection list 2. So set list 1 intersection list 2. Since they're all distinct objects, so set list 1, we shouldn't have a problem. So set stores A, we shouldn't have a problem. Dot intersection stores B. So it should give me the list with the intersecting object if len inter is greater than 0. That means there's an intersecting object. Return that first object, because there's only one intersection. You can't have two intersections. Return inter 0, else return none. I think this should be good. Time limit exceeded still, even with a set and intersections. Is that not good enough? Why? This is O of n plus m. You kind of just have to go through each list and figure out or I have this here. I can go through this list. Okay, I have stores A. I already saved this. This isn't stores A. Now I can go while head equals none. Stores B. Okay, well, let's try another method. Let's try another theory. So if these two are taking too long, I already traversed A, so this is O of n. If they gave me a clue here for O of n plus m, so now I could just traverse B and see if it's in A, right? So stores B. So for example, let's start at the head node, right? So if head B in head A. Return head B. So this tells me right here, I'm going through each object. Oh, fuck. No. Is that why? Is that why? It's because I fucking had a typo here. Oh my gosh. Okay, so basically this is another method that should work. It's simple. It goes through O of n plus m time. So you just add the time complexity of these two loops and two lengths. So if these two were the same length, let's just put that into perspective. This would be O of n, O of n. That's O of 2n. Right? When you have two lengths, two lists of different lengths, you have O of m and n. So you get n plus n. That's why you don't get 2n. Right? So I already did O of n. Now I go through O of m, right, of this list. Now I'm checking each element. If each element is in head A, okay. So let's run it. Let's run that. You serious? If head B, no. If head B in stores A. I'm just checking if this element is in stores of the stored elements. So I can even delete this. There we go. Can I submit it? Time limit exceeded. Why? Why is my time limit exceeding? Oh, because they're just doing a huge ass list of numbers. So the solution works, it's just that if you scale the input over time, it takes too long. But the logic makes sense. So when you store elements in an array of objects, you're not comparing the value, you're comparing the object itself. Each object has a unique ID. So when you say if head B is in there, you're saying is this object in this list? So I solved it. It's just that when you scale the list to 1,000 different things, it just takes forever. So I'm trying to figure out how to reduce time complexity of this. This is where time complexity comes into play. How can I reduce my time complexity to solve this problem? So now I've made it lightweight. I could actually just do tortoise and hare. Stores A. I can make one list go faster than the other, but that doesn't guarantee, or it could even skip the node. That's the thing I'm scared of. Okay, how would I take this? So this is the issue. This input scales with size. It's never constant. This isn't actually a constant time. So the stores actually stays constant in memory for the one problem. But as the problem changes, this stores increases with the scale of the number of nodes. So I need to figure out a way to reduce my memory to O of 1. Follow up, could you write a solution of n and use only O of 1 memory? I have O of n memory right now because it's the length of the nodes of head A's list. I don't know the technique to do this, so all my test cases pass because it works. This is a logical solution that works, right? Let's try the intersect method again. I'm just curious to see if the intersect method works I have to try it. You see here, because I had AB. What if I just fix that? So if I have O of M, right? I have my two stores. I check whatever the fuck it is, and then I just intersect them. There's only one intersection at most. So if this is true, I just return it. I return the list, and the first element in that list is the object. Right? So if that's true, let's try it. Let's try it. What? The fuck is wrong with this? Okay, intersected at 4. How the? Oh, maybe it's no, but it should be comparing objects, not set stores A, intersection stores B. I'm not checking values, I'm checking objects. So why does it intersect at 4, intersected at 8? Intersection, Python. Why do I go to the history? Check a pointer share the same memory. Let me see. So right now this is too, it's not lightweight. So let's check this. I was better off at appending everything, getting an O of N memory. You just keep traversing. So right now, let's go back to here. If head B in stores A, return head A dot next, head B dot next. I'm thinking return head B. This is the lightweight function that works. It works in test, but when you expand on inputs, it doesn't work. So let's try ChatGPT. This is where we're at 43 minutes now, so I have to look at a more efficient way to do this. So chat GPT. So I know my solution works. Now I'm trying to basically figure out what's the optimal way to solve, because I don't know the optimal way to solve it right now. Control V. Instructions. Okay, then I go close this. So you guys do get the way I solved it. It's just that now we have to fucking make it work. We got 37 out of 39 test cases solved. That means it's just the sheer number of inputs is just too high. So you have to have O of 1 memory. That's the only way you can retain your O of N plus M time complexity. I think right now I have an O of N times M time complexity, not an O of N plus M. So I have to figure it out. The solution you provided uses O of M additional memory, where M is length of the list A, by storing all the nodes of list A and then checking if B exists in that list. However, you can improve the solution by using a two-pointer technique. Yep, I called that out. So optimized solution for two-pointer approach. Use two pointers and that traverse the two lists. When a pointer reaches the end of a list, it is redirected to the start of the other list. If the two lists intersect, the pointers will eventually meet at the intersecting node n plus n. If they don't, okay, so basically one list is going to be shorter than the other is what it's saying. When a pointer reaches the end of a list, it is redirected to the start of the other list. Okay, interesting. If they don't intersect, both pointers will end up in none. Here's the code implementation. Okay. So if not head A or head B, return none. Can that even occur? 1 to m. Okay. Pointer A head A, pointer B head B. Okay, cool. While pointer A is not equal to pointer B, so pointer A dot next if pointer A else head B. Okay, so it's a while loop that uses pointer A dot next if pointer A okay, return pointer A. Two pointers, A and B, are initialized to the heads of the list A and B. Okay, that makes sense. Each pointer traverses its respective list. Okay. Pointer reaches the end of its list, it resets to the head of the other list. Okay, why? If there's an intersection, the pointers will eventually point to the same node. How? The loop continues until the two pointers meet. If the lists intersect, the meeting point is the intersection node. If not, both the pointers will eventually be none and the function returns none. Is that true? Oh, while pointer A is not equal to pointer B. Okay, let's play it out. Let's look at this. Let's look at this. So A, next, A. So A, B, next, A, B, next, A, B, next, A, B, next, A, B, next. A is if A is null, start at B. Okay, so A, B, next. A, B is null, it starts A, B, A, B, A, and then B. And if A and B are the same, oh, okay. So if A or B are the same, then it breaks out of the loop. until it hits null. Until they both hit null. So they either both hit an intersect or they both hit null. That's basically what it's saying. So it basically does use tortoise and hare, but for two separate lists. So what it's trying to do here is it's saying get rid of the memory. Just create memory for your pointers. So pointer A equals head A, pointer B equals head B. Now we only need one while loop. So we're trying to find the intersection of the two, and we're using the start of the opposite lists to trigger an intersection either at null or an intersection at the node. So the whole point of this is because it's O of n plus m, you're either bound to overlap at a null point or the actual node. And if you do overlap at the node, it breaks out of the loop. If you overlap at the null, then it means you've traversed everything in those lists and it doesn't overlap. So head B, and let's see what they did. So pointer A, so next pointer A equals, is this a ternary? If else. No, they just use an if else. Okay, so pointer A dot next. If pointer A else head B. If pointer A. So if this is not null, keep going, pointer next. So this is a ternary for, say your ternary in Python, else head B. So start at the next list. You're trying to force an intersection point is what it's doing here. So pointer B is equal to pointer, that's basically saying if pointer B else head A, then you just have to return pointer A because they intersect. So it doesn't matter which one you return. Time limit exceeded again. Okay, this is getting kind of annoying. How else would you do it? Pointer B dot next, pointer B head A. Head A, head B. Oh, that's why. We're not looking at head A, head B. We're looking at pointers. So this would become an infinite loop. So pointer A equals pointer B. This is an O of n plus m time. So there's no way you could overdo the time. You can only overdo the time if you're an O of n squared or O of n times m. Because now you're multiplying, you're scaling the inputs times the amount of other inputs. So you have to times it by every fucking element, right? But when you're doing it like this, you just add them. It's and you can get rid of the exponent. So it's just O of n plus m. So if we submit that, this should work. What do you know? It beats 22.1% of the solutions. So yeah, that's how you solve it. So we solved it using the original way that I had. It's just that I had O of n memory. So if you have O of n memory, you have to compare it against every memory slot. So that makes my time complexity O of m times n, right? We want O of m plus n. So this is the big discrepancy. of why this solution works and my other solution didn't work, because it passed all the test cases here, right? But that doesn't necessarily mean it'll pass a test case at 1,000 elements, at 1,000,000 elements, right? So we have to keep in mind the constraints, that they probably give you a hint with the constraint. So this is where you kind of have to be a little bit intuitive. So this answer I wouldn't have thought of about off the top of my head, but this is why we do this, right? We do this so that we can expand our thought process and figure out where we can create the value to solve this, right? So I had a solution, it worked, but it was too slow, right? And it took up too much memory, right? So this solution is a bit more lightweight. It takes up O of 1 memory and O of n plus m space, time complexity. So if you like this video, please give it a thumbs up. Please leave your comments in the comment section below and subscribe to the channel. Knologist out.